Alright, so we are going to start 10.4, the next lesson. And as you can see from the name, this is called the area of a triangle. All of you have seen the area of a triangle, but it is more with the right angle because you use the height. The height is always right angle to the base, right? So the formula that you have known for a few years now, maybe from middle school or wherever you learned the area of a triangle, is area equals to half base times height. So it looks like this, right? If this is your triangle, this is my base and this is the height. The height is always 90 degrees to the base. Or you can look at a right angle triangle. In a right angle triangle, this could be treated as my base and this could be treated as the height. But so this is what we know of. This is what we know of. So use this when you know the base and the height. Sorry, this has already been filled in. So I'm just going to talk through this, and you can fill in as we speak. Okay, so let's talk about the area of an oblique triangle. Remember, we use the law of sine, law of cosine to find missing sides and angle of an oblique triangle. Oblique triangle means it is not necessarily a right angle triangle. So there are two formulas actually that involve an oblique triangle. One is this formula that I have blocked here. Area equals to half AB sine C. They're all the same. They're all the same formula using just two different sides. And the second kind of formula where you use for the oblique is called, that has a name. This one doesn't really have a name, it's just area of oblique triangle. This one has a name called Heron's formula because this is the person who kind of invented this formula. That's this formula. Okay, let's see what the difference between them. Let's do it one at a time. Okay, and before I forget, both these formulas are on the formula sheet that I spoke to you about. So I'm just going to flip the pages, you don't have to. But so this is where the formula sheet is, and it's there in your notes packet too. This formula sheet, formulas, it's basically almost the next page. Law of sine, law of cosine, and then here are the two formulas, area of oblique triangle and the Heron's formula. But each section has the same formulas being written. So we're going to see both of these right now. Okay, so going back to that. So we're going to first talk about this, and then we're going to talk about this. Okay. So let's look at this formula. So if you look at this formula, this one, it says that this is used when you know SAS. What do we mean by that? SAS basically means side, angle, side. What do we mean by that? It means that if you have the measurement of two sides and the angle in between, this is called as an included angle. So let's look at this one, for example. So whenever you have a triangle, we've seen this, we mark them as ABC. So this triangle is ABC. So A, B, C. And remember how we mark the sides. Opposite angle A is small a, opposite angle B is small b, opposite angle C is small c. These are the sides. So if someone gives me, let's look at the first formula. Half AB, so that means I'm using this side and this side. And then it says sine C. This is, remember, the input for sine is an angle. So this is sine theta, so it's an angle. So then you use this. So what do you notice here? I'm using two sides and the angle in between, the included angle. That's why it talks about SAS. And it's true of all the other two variation of the same formula. BC, so if I take B and C, if I take these two sides, I use the angle in between, sine A. So that is why you use this formula when you do SAS. And obviously when we start working on problems, you see how it's being used. The next formula, called Heron's formula, use this when you know SSS. What do we mean by SSS? Side, side, side. When you know all three sides. When you know all three sides. That means you know the measurements of A, B and C. Okay. So what's this formula looks like? So let's look at this. This is a formula. Area equals square root of this. And if you look at this formula, what do you notice? It has A, B and C. It has all the three sides. It has no angles. It has all the three sides. But what else do you notice? You also notice that it has a small alphabet S. What does that stand for? That stands for something called as where S is the semi-perimeter. What do we mean by semi-perimeter? We all know what perimeter means. We all know what perimeter means. Perimeter is when you add all the sides, whether you're talking about triangle, rectangle, whatever. Now we're talking about triangle. So in this triangle, if you look at this triangle, what is the perimeter of this triangle? A plus B plus C. And what does the word semi mean? Half of that, right? So that is why the formula for S, which is a semi-perimeter, is A plus B plus C divided by 2. Or the same thing can also be written as A plus B plus C and half of that. Both are exactly the same, just different ways of writing it. Okay, so this is a situation where you notice in both the situations I'm not using the right angle. There's no question of the height, therefore there's no question of the right angle being talked about or being used. Okay, one thing we want to talk about is when you're talking about SSS, when all three sides are given to you, you want to make sure that you can create a triangle with those three measurements that you're given. Now we're going back to geometry days. We're going back to geometry days when you were given three measurements of the sides and you were asked, can you actually create a triangle with these measurements? Do you guys remember what the rule was? So basically, if I take I'm going to go ahead and use the paper. So, okay, let's first write this down. Let's see. So it basically has to follow triangle inequality theorem, which says sum of the two small sides must be greater than the largest side. So sum of the two small sides must be greater than the largest side. What does that mean? Okay, let's just take some numbers. So let's say I have a triangle where it is 1 centimeters, 2 centimeters and 3 centimeters. Can I form a triangle with this? So let's look at this. Sum of the two small sides, those are my sides. So 1 plus 2 must be greater. It doesn't say greater than or equal to, it has to be greater, than 3. Is 1 plus 2 greater than 3? No, it's equal to but not greater. So I cannot form a triangle with these three measurements. So that's why they've kind of asked us they've given us three examples, A, B and C, and let's find out. So determine if the three sides form a triangle. 2, 3, 4. Two small sides, 2 plus 3. 2 plus 3 has to be greater than 4. Is it greater? Yes, it is. 5, 2 plus 3 is 5. 5 is greater than 4. Therefore, I put a tick mark. Okay, what about this one? This one I just did. 1 plus 2 has to be greater than 3. Not possible, right? It's equal. 1, 1 and 3. 1 and 1. 1 plus 1 greater than 3. Not possible. 2 is not greater than 3. So these two don't work, but this one works. So whenever you're given three sides of a triangle, a lot of times they will say, check if the three sides will form a triangle before you do any work with it. Okay. So now let's go ahead. So that is one of the things that you need to check. But let's go ahead and look at what the problems that they've given us. So let's look at the first one. Okay, first of all, what are they asking us? Find the area of the given triangles from problems 1 to 4. Okay, so let's look at the first problem. In the first problem, 2 centimeters, 5 centimeters, 20 degrees in this triangle. What do you notice? We notice that one side has been given, another side has been given, two sides have been given, and an angle in between. The angle is in between the two sides. Therefore, I have been given SAS. Therefore, I can use my first formula, which allows me when there is two sides and an included angle given. So it's going to be this. So it's going to be half of, area is half of A times B. It doesn't matter which, basically half of side times side, half of A times, here we go, sorry, A times B. So B side, it doesn't matter which side, basically half of this times this multiplied by the sine of the angle in between, multiplied by sine of 20 degrees. So this is what the formula tells you to use. Now all you're going to do is the math. So when you're doing this math, I can cancel this. So I'm left with sine of sine 20, 5 times, not 5 of, 5 times sine of 20. And sine of 20, I need to use my calculator because sine of 20 is not on the unit circle. So you just use your calculator. This is a calculator heavy unit anyway. So use your calculator, put this in your calculator and take your time. You can hit pause anytime to make sure your answer is correct, and you should get this. Area should be equal to this. And what do you notice? I put centimeter square, or you can say square centimeter, doesn't matter. If they give you a unit of measurement in the question, if the question has a unit of measurement, your final answer should always have the unit of measurement. Alright, going on to problem number 2. What do you notice? This is my triangle and I have been given three sides. Therefore, it's SSS, therefore I can use my Heron's formula. What does the Heron's formula say? This is my Heron's formula. So I have A, B and C, the three sides, but what I don't have is the S, the semi-perimeter. How do you find the semi-perimeter? 5 plus 6 plus 8 divided by 2, because semi, right? So you add the three sides and divide by 2. And it could be a decimal. In this case, it is a decimal because not everything is divisible. An odd number is not divisible by 2. So it's 9.5. Use this 9.5 in your formula. Area equals to square root of S minus A, S minus B, S minus C. S is 9.5, 9.5, 9.5 minus 5, 9.5 minus 6, 9.5 minus 8, square root of that. Put this in your calculator. You can hit pause and go ahead and make sure that you get this answer. And it is inches square or square inches. You can write it either of the ways. Alright, so make sure you get this answer. Okay, I'm going to keep going. You can always hit pause anytime you want to do your calculations and check your answer. Let's look at problem number 3. Problem number 3 does not give us a diagram. It does not give us a diagram. It just gives us the measurement. So let's see, let's draw the triangle. So if I draw the triangle, I mark my triangle as A, B and C. Small a, small b and small c. B is 4 centimeters. C is 1 centimeter. And angle B is 50 degrees. Okay, so let me go ahead and take this off so that it's easy for me to do the work. So what I notice is, I have two sides. I do have two sides, but unfortunately, I don't have the angle in between. Can I find the angle in between? Well, I think I can. I can use my law of sine. What I notice is, I can find, I do have an angle and a side opposite to that given. So I can try to set up law of sine. Sorry, here we go. I can try to set up law of sine and see if I can find the missing angle in between B and C, because that's what I need. You need two sides and angle. Okay, so let's see. Let me try. So I'm going to do sine of 50 degrees over 4 equals to, thing is I can't do, even though I need to find angle A, I can't do this because I don't have the opposite side. So maybe I can find this in the end, but I can do this. Sine of C over, what is opposite to sine of C? 1. So basically, sine of C equals, I can ignore the 1, sine of 50 degree over 4. So angle C equals sine inverse of sine of 50 degrees over 4. I'm just writing this. So put this in your calculator, find what is angle C. So you can hit pause, do this in your calculator, and you should find angle C equals to 11.041. Once I have angle C, can I find angle A? Of course, because if this is 11.041, I have this angle. Whenever you have two angles, you can always find the third angle by subtracting from 180 degrees minus these two angles should give you 50 plus 11.041. Put this in your calculator, and what do you get? Sorry, I have to look for my calculator. 959 degrees. Everybody okay? Now I have two angles, and I found the angle in between, and I just found angle A. So now I can use the area of the oblique triangle, which is area equals half of 1 times 4 times sine of 118.959 degrees. So go ahead and put this in your calculator and see what you get. So do your work and go ahead and check, and you should all see 1.750 centimeters square. So this is my problem number 3. Alright, now let's look at problem number 4. So I noticed that even in problem number 4, I don't have a... actually, problem number 4, I'll let you guys work by yourself. Let me just get you guys started. So I have... You draw the triangle because I see they've given me some piece of information. So A, B, C, that's how I draw my triangle. And small a, small b, small c, what all have they given me? A equals to 4 inches. That's right here. They've given me this. And then angle B equals to 32 degrees. So they've given me this. And what else have they? Angle C equals to 17 degrees. They have given me this. What I notice is they've given me two angles, but only one side. So I need to find one more side. I can find either this, because this B side, A side, and the angle in between, or I need to find this side. That way I'll use A, C, and the angle between. So it doesn't matter which side you find, because you have both these angles, and if this side it's this, this, and this. If it's this side, it's this, this, and this. So why don't you guys go ahead and do the work? So you will again use the law of sine, where you will set up. So having said that, I forgot to mention one thing. They have given you two angles. Whenever you have two angles, you can always find the third angle by subtracting from 180. So hopefully you all got 131. Now you can use your law of sine, because you have this side and the angle opposite. Please set it up. You start by saying sine of 131 degrees over 4 equals to, find either of the sides. Maybe I'll do B. So sine of opposite B is 32 degrees over B. Solve for B. Once you've solved for B, you'll use your area formula, because half of 4 times whatever you sine for B multiplied by sine of 17, because now you'll use angle 17, right? You'll use angle 17, because that's what is in between these two. And see if you can get this. Alright, okay. I'll pause for 30 seconds and then we'll go to the next page. Next page has a few word problems, so we need to work through that. Alright, let's go to the next page. Okay, so let's look at the first problem. It says find, okay, this one also actually does not have a diagram. I drew the diagram. So I'm going to just cover it up so we can start working on it from the beginning. Find the area of a segment of a circle. What is a segment? So that's a new thing. And I want to make sure that you guys understand what a segment is. Find the area of a segment of a circle whose radius, first of all, let's draw a circle. I know I'm working with a circle. Okay, let's see. Okay, sort of, maybe halfway decent circle. Find the area of a segment of a circle whose radius is 5 inches. So this much I know. This is 5 inches. That much I know. Formed by the central angle. Do you guys all remember what a central angle is? This actually, now I'm looking at the circle. The circle is so bad. But do you guys all know what a central angle is? Central angle is the angle that's being formed in the center of the angle with another radius. So this will be my 40 degrees. And this is also 5 inches. And what do we need to find? We need to find the segment of a circle. Okay, so let's see what are the things we know. The angle that's being formed by the central angle, this is an arc. But this whole part that's being formed by the central angle is called as the sector. Do you guys remember this from your geometry days? Sector of a circle. One part of the circle. How do you find the area of the sector? You'll say, oh, we'll get to that. Okay, we'll get to as to what it is. Okay, so this is a sector, but what is actually a segment? Segment is nothing but from this sector, this is called a sector, I make a triangle. This is a sector. It's almost like this is your sector. It's almost like if this is a pizza slice, the crust will be the segment. So they want to know the area of this segment, of this pink line. Okay. So if I can find the area of this entire sector is this whole pizza slice. This plus yellow plus pink. So if I can find the area of the sector, and then if I can find the area of, area of the triangle, the yellow part, which I think I can because I have two sides and an angle in between, I will get the area of my segment, which is the area of the whole sector minus area of the triangle. Is that clear? This pink thing is nothing but the whole pizza slice minus the triangle that formed by the yellow. Okay, so let's see if I can find the area of a sector. Yes, you should be able to find the area of a sector because this is going back to your geometry days. This yellow thing, this whole thing, yellow plus pink, is a part of a triangle. What part of a triangle is it? My entire triangle is 360 degrees, 40 degrees part of it. So basically 40 degrees over 360 multiplied by the area of the circle, which is pi r square, 5 square is 25. I can simplify this. 1/9, because 4 over 36 is 9, 1/9 of 25 pi. Go ahead, you can leave it like that. Maybe we can put it all towards the end in the calculator, or you can find it. I don't care. Then let's try to find the area of the triangle. Area of the triangle should not be difficult. We are just coming out of trying to find the area of a triangle using the area of the oblique triangle. So half, because it's SAS. Two sides multiplied by sine of 40 degrees. Please put this in your calculator, see what you get, subtract them and see what you get. And basically, area of the segment, we should all get this as, I'm going to let you do the math in the calculator. You can hit pause, do the math, and you should get it as 0.692. This is in inches, so you can do inch square or square inch, doesn't matter which way you write it. That is your answer for number 5. All right, yeah, that's one. Okay, now let's go to another problem. This problem is right here, and this one actually they give you the diagram. So we'll try to work some of it looking at the diagram, and we'll finish it up. Find the area of the shaded region. So you can see this. This is what they've given us. They've given this as 10 inches. This is 8 inches. This is something I drew, the right angle. Find the area of the shade in a semicircle. So this is a semicircle. What is a semicircle? Take a circle and cut it in half. So this is a semicircle with a diameter of 10 inches. If the diameter is 10 inches, my radius is 5 inches, because I mostly work with radius. The length of the chord AB, this chord AB, is 8 inches. And this is 10 inches. And then, going back to your geometry days, what do I know about this triangle? Any triangle in a semicircle, this is my semicircle. If I draw any triangle in a semicircle, that will always be a this triangle, right angle triangle. This triangle, doesn't matter where you draw this. And this one goes right in the middle. All of them will be right angle triangle. That means this shaded triangle is a right angle triangle. So basically, for me to find the area of the shaded, I can find the area of the semicircle, I can find the area of the triangle and subtract. For me to find the area of the triangle, I can do, this is actually a right angle triangle, so half base times height works. So for me, so this could be the height, this could be the base, or vice versa. But what is the measurement of this? Do not tell me 8. They're not necessarily for it to be 8. Then nowhere does it tell you that this is an isosceles right triangle. But what you do know is it is a right triangle. That means you can do Pythagorean theorem. 8 squared plus x squared equals 10 squared. Therefore, I get x to be 6 inches. So let's find the area of this triangle. So area of this triangle is half base times height. Base times height. That's the area of the triangle. Then area of the semicircle. Area of the semicircle. We know that area of a circle is pi r squared, but we want half of that. And then area of the shaded portion equals area of the semicircle, right? Because that's a large one. We don't need this. Area of the entire semicircle. Okay, sorry, let me drag it down. Area of this entire semicircle minus area of the triangle. So go ahead and do the math. Put this in the calculator, subtract them, and what do you get for this? So we should all get, you can hit pause, but basically I got 15,270 inch square. All right. Okay, so that is your problem number 6. This is your problem number 6. And then let's do one more. Because these word problems are actually, you see them a lot. Okay, let's look at this. So I'm looking at number 7. So it says if a gallon of paint covers 400 square feet. So 1 gallon of paint covers 400 square feet. How many gallons are needed to paint a triangular deck? Okay, I've never seen a triangular deck, but yeah, I'm assuming it exists. So this is a triangle, and we're saying it's a deck, and the sides of the triangle are 65 feet, 72 feet, and 88 feet. How many gallons of paint do I need to paint this deck? So what do I need to find? I need to find the area. Everybody agrees? If I know the area, I can find out how many gallons of paint do I need. So which formula will we use? Because this is SSS, I'll use the Heron's formula, before I do that, for which I need the small s. Small s is going to be 65 plus 72 plus 88 divided by 2. Go ahead and please do the math and tell me what you get. Everybody okay? So that is the value of S. S is basically semi-perimeter. Okay, then now I'm all ready to find the area. So area is going to be 112.5 minus 65, 112.5 minus 72, 112.5 minus 88, right? Isn't that what the formula is? Minus A, minus B, minus C. Doesn't matter what order you put it in. Please put this in your calculator, find the square root, and please do the work, hit pause and finish the work, and you will find the area to be 2302.680 square feet. This is feet, so the area will be in square feet. Everybody okay? But that's not what I need to find. It's not asking for the area. It says how many gallons of paint do I need? Okay, so 1 gallon has 400 square feet. If 1 gallon has 400 square feet, so basically 400 square feet requires 1 gallon. Therefore, 2302.680 requires X gallons. How will you solve this? So I think it looks like approximately maybe 4 times 6 is to 24, right? So it's about, but let's do the math. Go ahead and find what the value of X is. You can cross multiply. This times this equals this times this, and then divide. Go ahead and do the cross multiplication and get X by itself. You should get 5.757 gallons. But you don't buy, gallons of paint is not sold in decimals, so basically you will buy 6 gallons of paint to paint this deck. Okay, so we will stop here, and there's one more problem, but I'll let you guys work on this by yourself. You have the key with you. The key has been posted as always in the notes folder. Go ahead and take a look at it and see if you can solve this by yourself, and we will stop this recording now.